Okay, so this is just a brief overview for the topic C review. First thing we need to talk about is we need to talk about some vocabulary. So when we're talking similar means that the figures look exactly the same, except for the sides are not the same length, but they are all proportional, which means like all the sides are doubled or all the sides are half. They'll all be um, proportional in the same way. So not the same sides, but everything else is the same. The angles are same, the figure looks the same. It's just that it's been in some way dilated. And the symbol for similar is this. So we want to say um, sides are proportional. So they've had some kind of dilation. Congruent means it's exactly the same. A rigid motion, remember that a rigid motion is our translation, reflection, and rotation only. And a rigid motion preserves angles and side lengths. So, in other words, you have the exact same figure. Everything is exactly the same. It's only been moved. Okay, now remember that a translation is like skating. So a translation is just a rigid motion where it has been moved along a vector. Don't forget, a vector has magnitude and direction. Magnitude meaning a length, direction meaning which way it's going. Okay, a reflection, it usually has a line of reflection. And there's all kinds of reflections. We did reflections over the x-axis. So remember, when you go over the x-axis, it's like you're going up and down. So that's your y values. Reflection over the y-axis, which means you're going left and right, which is your x values. And we did y equals x, which is the line that goes up, and y equals negative x. We've done all kinds of reflections. A rotation. And a rotation, it depends. If you're going counterclockwise, it's positive, and if you go clockwise, it's negative. And remember, with a rotation, you need a point of rotation, and you need an angle, so you know how far to rotate it. Now, a dilation is not a rigid motion, and a dilation is like making something big or small. And it's where you are multiplying. You're multiplying by a common factor. But we'll get more into that later. I just want you to understand that a dilation does change your figure. It changes the sides, not the angles. Okay, mapping. Mapping is when you take a pre-image and you put it onto an image. So this is it's like, what kind of transformation did you do? I had to do a rotation of negative 30 degrees to take the pre-image onto the image. So this is putting a pre-image onto an image. What kind of transformation did you do? Okay, remember, the image is when you're done. And the pre-image is what you start with. Okay, when a figure has been transformed through a series of rigid, that's the key word, motion, what stays the same? Well, think about it. You're not changing the figure at all. You picked it up and you moved it somewhere. So obviously the area is the same, the perimeter is the same, the corresponding angles are the same, the corresponding sides are the same, the side lengths are the same, the angle measurements are the same, but the coordinates are not the same, because remember, what you did is you moved it. Okay, so we're going to go through and do this one here. It says the graph ABC with the vertices 7, -2, 8, negative, so on, and its image after the following transformation. So give the coordinates of the final image. So what we're going to do is we're going to go through and we're going to do this complete transformation. So the first thing I'm going to start with is I'm going to start with the original figure. So 1, 2, 3, 4, 5, 6, 7, -2 is A. And then 8, 1, 2, 3, 4, 5 is B. And then 3, -8. This is C. So this is my original figure. Okay, so now I'm going to do a translation. And let's go ahead and just change that to red. Why not? We'll do red as the translation. And we're going to go -9, 10, which means I'm going to take my A, I'm going to take my X values and go 1, 2, 3, 4, 5, 6, 7, 8, 9. And my Y value is 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is a prime. I'm going to do the exact same thing with the B. I'm going to go -9, +10. So 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And do C. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then I'm going to go 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is C prime. And that is with the translation. Now, the next thing I'm going to do is I'm going to rotate it 270 degrees. So if you remember with the rotation, you go Y -X for the 270 degrees. So I need to think about my original one. So I'm at, A is at -2, 8, because I'm going to change them. So B is at -1, 5, and C is at -6, 2. So that means my new one is going to be flip them and change my X's sign. So flip and change my X sign, flip and change my X sign. So now I'm at 8, 2. That's a double prime. And 5, 1, 2, 3, 4, 5, 1. This is my B double prime. And then 2, 1, 2, 3, 4, 5, 2, 6 is my C double prime. Almost done. The last thing I'm going to do is I'm going to reflect it over the line Y equals -X. So Y equals -X is this line right here. And when I reflect it over that, that's when I have to change everything to -Y, -X. So my final one is going to be, now do I really need to plot it? I guess I could, but it's going to be, I'm going to take these values here, -2, -8. So -1, -5, -6, -2. So it's going to be -2, -8 is my final one, and -1, 1, 2, 3, 4, -5. And -6, 1, 2, 3, 4, 5, 6, -2. Ta-da! There's my final one. Okay, moving on to the next one, we need to write a rule. And so when we write a rule, what we need to do is say what happened from our pre-image, which is this figure right here. How did I go from there to my image? So if you look, I went, for the X values, I went 1, 2, 3. So X plus 3. And then from there, I went down 1. Y minus 1. There you go. Okay, now we've got a square with the vertices -6, la 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 la. Reflect the square over the y-axis, then reflect the original. We want to reflect that over the x-axis. So we're not taking it each time, we're just doing our original one and first reflecting over the y-axis. So let's get the original figure first. So I've got -6, 7. That's B, and I got -2, 6. That's C. -3, 2 is D, and -7, 3 is E. Okay, this is my original, my pre-image. So the first time I'm going to reflect it over the y-axis. So remember, I always say we should highlight what we are reflecting over. Okay, so I'm going to reflect it over the y-axis. So if you think about it, what I'm really doing is I'm just changing my x values, because I'm going from left to right. So if I change my x values, this should be 6, 7, 2, 6, 3, 2, 7, 3. Let's go ahead and do it. So 6, 7 is B prime. 2, 6 is C prime. 3, 2 is D prime. And 7, 3 is E prime. That's reflected over the y-axis. Okay, so let's do the next one. And this time, we're going to reflect over the x-axis. So when I reflect over the x-axis, this time my y is changed. So -6, -7, -2, -6, -3, -2. And -7, -3. So -6, -7 is my B prime this time. -2, -6 is my C prime. -3, -2 is my D prime. And -7, -3 is my E prime. There you go. Okay, now what sequence of rigid transformations would map the pre-image, which is my original image? So that would be this one right here. What sequence of rigid transformations would map my pre-image ABC onto the final image? So the first thing I need to think about is what happened from here to here. And if you look, it is a reflection, and I reflected over the segment DE. And then the next one is I'm going from here to here. So if you'll notice, this is a vector, so I did a translation along my vector B prime B double prime in that direction. And then the next thing I did is I went from here to here, and that's a rotation. And I rotated about a triple prime. Now, of course, we can go in, we can find out the angle and all that, but I'm not going to worry about that at the present time. I just want to see what kind of transformations did I do in order to map the original onto my final figure. Okay, what are all the transformations that can map this figure onto itself? So really what we're talking about here is we're talking about symmetry. So what I could do if I had, let's just say this is the midpoint of these sides. So if I had this line here, that would be a line of symmetry. Let's just call it L. So I could reflect over L. Another thing I could do is, let's say this line right here, I could do a line of symmetry here as well. We'll call this M. So I could reflect over M. Another thing I could do is from this center point, I could rotate it 180 degrees. So that means it has the point of symmetry and it has rotation symmetry. So I could rotate 180 degrees. Okay, so we're going to do this next one. We're going to figure out what our original point was, our pre-image, given the image. But I do want to change something, is make this, instead of x equals 5, make it x equals -2. It didn't work out correctly, so change that. Okay, so the first thing we're going to do is we're going to plot our image, which is -5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, -6. And then, since we're working backwards, we have to do our reflection first. We're going to reflect over, so let me highlight. Remember, we always highlight what we're reflecting over. I'm going to reflect over here. So 1, 2, 3. So 1, 2, 3 is my reflection point. And my reflection point will be 1, -6. The next thing I have to do is do my translation. So I want to say x minus 7 equals 1. That means x equals 8. Add 7 to both sides. And y minus 9 equals -6. I'm getting it from here. So add 9, that means y, that's a 9, equals 3. So my point is 8, 3. Okay, now the final thing that we're going to talk about here is what transformations could you use to prove that ABC is congruent to YXZ, which means how do we map it onto itself? So I guess one of the things I could do is what I could do is I could rotate about this point over here so that my new figure would be somewhere like here. And then I could reflect. So rotate about, oops. And then I could reflect it over XY. So then I could take my figure and I could reflect this over here and get my original figure. Okay, we're done.